All right, now that we've had a little stretching break, hopefully we're ready to plug in some more numbers and help understand how the formula affects the graph to help try to memorize which of these formulas goes with which graphs. So, for example, let's start with this 1 over x squared here. So, if we want to find f of -2, for example, f of -2 is going to be 1 over its input squared, so that means 1 over -2 squared. And -2 squared is +4, so this becomes 1 over +4, also known as 0.25. So you get that one in here. And in general, if you plug in larger values of x into this, or even bigger negative numbers, either way, you're going to get 1 divided by a really big number, which should get you closer to 0. So it's going to have this point -2.25 right here. If you plug in -3, it's going to be even closer to 0. And in general, it's going to have another horizontal asymptote on that side. If you plug in -1, you'll get 1 over 1, which is 1. Plugging in -0.5 will give you 1 over a small number squared. -0.5 squared is going to be -0.25. So this should end up being 1 over, sorry, it should be +0.25. So that gives you a result of 4. Because a negative number squared is still positive, so you get 4 here. That gives you this point. When x is -0.5, y should be 4. We had this one, so in general, if you plug in numbers closer to 0, you're just going to get 1 divided by a number closer to 0 squared. Is going to be 1 divided by a really small number, gives you a really big result for y, so it just goes up from there. And plugging in 0 still makes this undefined, so 1 over 0 is not a number. So there is no y-intercept here. If you plug in 1, you'll just get 1 over 1, which is 1. 1 over 2 squared will become 1 over 4, which is 0.25. So it's got that point and that point. Also, I didn't mention this, but if you plug in something like x equals +0.5, you'll still get 1 over 4, or sorry, 1 over 0.25, which gives you 4. So this one is symmetrical across the y-axis like this. And it still has an asymptote on the y-axis is an asymptote, and the x-axis is also an asymptote. Okay, here's the square root. Let's start off. By the way, I'm picking these values of x for you. If you were going to do this by hand, you could probably pick whichever values of x you want, and it would still work out. I'm picking values of x that I know will work out nicely. So for example, I'm going to want to do the square root of 9, because the square root of 9 is just 3 here. So in other words, g of 9 is 3. And if you do that with the rest of these, let's evaluate these. Mistake there. Whoops. Okay, yeah, so the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, so that gives you those points. What happens at -1? If you try to find g of -1, you're going to get the square root of -1, which is also known as I. It's an imaginary number. It doesn't actually show up on the y-axis, so we can't actually graph it. So there is no point here where the x coordinate is -1, or anything negative for that matter. This whole this whole side of the graph here is off limits because the square root of any negative number is undefined. But we can graph the rest of these. If you plug in x equals 0, you get y equals 0. X equals 1 gives you y equals 1. 4 gives you 2. And you notice that this looks a whole lot like a sideways parabola. That's really what it is. If you're talking about a square root instead of a regular parabola, that is so ugly. Let me try that again. That's a little better. Should be kind of roundish there. Yeah, if you're talking about square root instead of x squared, it turns it into a parabola. It just makes it sideways. But the radical sign only gives you positive results. You don't get the plus or minus square root. So otherwise it wouldn't be a function because it would fail the vertical line test if you had the negative results here. All right, here it is, 8 out of 8, the last one of these we need to graph. So I picked some values of x that I know it's easy to take the cube root of. So that's going to be the cube root of -8 here. Comes out to be -2. So that'll be -2. The cube root of -1 is -1 because -1 to the power 3 is -1. So it works both ways. The cube root of 0 is 0, the cube root of 1 is 1, and the cube root of 8 is 2. So this gives you a graph that looks a little bit like a square root in the sense that it's sideways, except the difference is that it's a little bit wider. You had to go out further to the right to 8 to get to y equals 2. So it's a little wider, and the main thing is that it is defined at negative values of x. You were not allowed to take a square root of those negative numbers, or you get something imaginary, so there's no points out here with the square root. But with negative values of x in a cube root, it's okay. So you get something that basically looks like that. Now, later in chapter 5 and also later in the class, it's going to be really helpful if I say, for example, what does the graph of y equals 1 over x look like? And if you know off the top of your head that, oh, it looks kind of like this, something like that, it will help out a lot. So you don't have to take forever to actually graph it on your calculator or actually plug in points every time. And if I ask you, what does the graph of y equals x cubed look like? If you just know that, oh, that's going to be sort of like a parabola on one side, but then you get upside down parabola on the other side, that will help you with a lot of stuff later on. So you're going to need to memorize it and memorize what these different 8 ones are. Here's my recommended way of doing it. I'm going to include a link to Quizlet, which is a site where you can make flashcards for free. And the link will take you to this page where here's my username, Ben Smith Math, made this thing called 8 Basic Graphs. And it's essentially these 8 flashcards where you see a graph and you have to name which function it goes with. So one way to study this is to use the flashcards button. This will work well. If you do flashcards, then you'll see a graph and you'll just try to name to yourself, what is this function? Is this 1 over x squared? No, it's 1 over x. Darn it, I was wrong. I thought it was 1 over x squared, but it was 1 over x. Okay, now I remember that one's 1 over x. And then you press this little forward button here to go forward, and then you try to name this graph, and then you might say, oh, I know that one, that's 1 over x. Press it to flip it over, or 1 over x squared, that's what I meant to say, of course, haha. Just testing you, yeah. It's 1 over x squared, and so you can do it that way, or the other thing that works pretty well is the matching thing. If you want to drag items onto each other to make them disappear. So, for example, the basic square root function, which one of these pictures is a graph of that? It is this one right here. So drag it onto there. Where's the 1 over x graph? Oh, that's 1 over x. So that's just another thing you can do to practice memorizing these. Some of these are they're not going to work very well. The writing, because you're going to have to match my symbols exactly, and that's no fun. You just want to basically know what it basically is. Okay, so I'll include this link again in the description and also in the homework items.pdf file.